Okay, now we're going to be talking about the image geometric variables. These are the factors that are going to be affecting our image. So now we're going to start by looking at the SID, or source to image distance. So this is the distance from the X-ray tube, so this one, to the detector. This distance is called SID. And if we have an increased SID, that's gonna decrease magnification and it's gonna improve detail. And if we have a low SID, that's gonna increase magnification and blur. So decreased SID, it's gonna be this tube being closer to the detector, and if we have an increased SID, this is gonna be the tube far from the detector. Okay, now let's move into SOD. This is our source to object distance. So in this case, our object is gonna be the hand. So this is our patient hand, and this is our X-ray tube. So the distance from the tube to the hand or object, that's gonna be our SOD, source to object distance. And if we have a big SOD, that's gonna be a object closer to the IR, so closer to the detector, that's gonna be an increased SOD. And if it's a decreased SOD, it's gonna be the hand is gonna be closer to the tube. So for example, if your hand was like here, the distance of the SOD is gonna be shorter, right? So it's gonna be a low SOD. And what is that gonna cause? That's gonna be a more magnification, because let's say your hand's here, so the magnification is gonna be way bigger than what it is if it's just closer to the detector, right? Or if the SOD it's bigger. Okay, now let's talk about OID. This is object to image distance. So again, we have our patient hand, and this is going to be our receptor. So the distance from the object to the detector, that's going to be OID. And if we have an increased OID, it's going to create more magnification and sharpness. And if it's a low OID, that's going to be a sharp edge and more accurate size of our object. So we want this hand to be actually touching the detector, so we have a more sharp and more accurate size of our image and our object. Okay, now we're gonna also be looking at the CR. This is the central rate alignment, so it's how we're gonna be positioning our beam. So basically, if there is any angle or direction that the main beam, it's relative to the object and the receptor. So that's gonna be controlling superimposition. What is superimposition? Basically is something over another thing. So in this case, we have this triangle, and if we just do this yellow part is gonna be superimposing this back figure, right? So if we look at this way, we'll say this is over this. So we're probably not going to be able to see this triangle, and if there is any distance from this triangle to the back figure. So it's just going to be superimposing, like if it was one. And if we create any angle, that's going to be so visual separation of the structures. If there is any angle to the CR, we're actually gonna be seeing that there is actually a distance from the triangle to the other figure. So I put a star here so you can actually know that this is gonna be talked on part C of our lab. So small changes in angle can drastically change structures overlap. So part C is gonna be covering this. Also, we're gonna be talking about shape distortions, so just elongations or any type of shape distortions. It's gonna be controlled by the central ray. And yeah, Also important to set the beam divergence. So it's how X-rays spread out from the point source. So this is what creates the magnification and distortion. And also the detector orientation, so the position of the receptor in relation to the beam. So if there is any, if it's perpendicular or any angles adding to it. So yeah, these are the variables that we are going to be taking into account when taking our image.